We humans are a peculiar species. We call ourselves Homo sapiens, the wise human. For a very long time, we were not the only humans on Earth. Imagine a world where several human species walked the land. Some were strong, like the Neanderthals. Others were small, like Homo floresiensis, the hobbits of Indonesia. This was the reality for most of human history. Different kinds of humans lived, loved, and struggled for survival. Yet today, only Homo sapiens remain. We are the lone survivors of a once diverse genus Homo. What happened to all the others? Did we outcompete them? Did we interbreed with them, absorbing their genes into our own? Or did we perhaps actively eliminate them? These are big questions that scientists still debate. The story of our survival is not just about us. It is also about those we left behind, those whose stories ended while ours continued. Our journey to becoming the sole human species is a long and fascinating one. It is a story filled with incredible adaptations, migrations across continents, and profound changes in how we lived. We started as just another animal, foraging for food and avoiding predators. But something changed. We developed tools, mastered fire, and created complex social structures. This essay will explore that incredible journey. The story of human evolution begins millions of years ago in Africa. Our earliest ancestors were ape-like creatures. They lived in forests and woodlands. Around 6 to 7 million years ago, a new lineage split off. This lineage would eventually lead to us, Homo sapiens. These early hominins, as scientists call them, started to walk upright on two legs. This was a crucial first step. Bipedalism freed their hands to carry tools, food, and infants. The genus Homo, our direct ancestral group, appeared around 2.5 million years ago. One of the earliest known members was Homo habilis, the handyman. Homo habilis was notable for making and using simple stone tools. This marked a significant cognitive leap. Following Homo habilis, other Homo species emerged. Homo erectus, the upright man, appeared about 1.9 million years ago. Homo erectus was a true pioneer. They were taller, had larger brains than habilis, and developed more sophisticated tools. Importantly, Homo erectus was the first human species to migrate out of Africa. Our own species, Homo sapiens, evolved in Africa around 300,000 years ago. Several key milestones mark the evolutionary journey of Homo sapiens. The development of bipedalism, as mentioned, was foundational. It set our ancestors apart from other apes. Walking on two legs was more energy efficient for long-distance travel across open savannas. This change in locomotion had cascading effects on our anatomy. It reshaped our pelvis, spine, legs, and feet. It also freed our hands, paving the way for tool use, a hallmark of human ingenuity. The mastery of fire was another transformative event. Fire provided warmth in cold climates, allowing humans to expand into new territories. It offered protection from predators, keeping dangerous animals at bay during the night. Perhaps most importantly, fire allowed humans to cook their food. Cooked food is easier to digest and provides more calories. This extra energy likely fueled the growth of our energy-hungry brains. The development of language and complex communication was arguably the most significant milestone. While other animals communicate, human language is unique in its complexity and flexibility. Language enabled unprecedented levels of cooperation. Over millions of years, the human body has undergone remarkable physical transformations. Our ancestors were much shorter than modern humans. For instance, Australopithecus afarensis, like the famous fossil Lucy, stood only about 3.5 to 4.5 feet tall. As hominins moved from forests to savannas, and as their diet changed, their stature gradually increased. Homo erectus was significantly taller, approaching modern human heights. This increase in height may have helped with spotting predators and dissipating heat in open environments. Bone density has also changed over time. Early hominins and even early Homo sapiens, who lived as hunter-gatherers, had very robust, dense bones. Their lifestyle was physically demanding. They walked long distances, hunted large animals, and engaged in strenuous activities daily. This constant physical stress stimulated bone growth and maintained high bone density. Their skeletons were built for a life of intense physical exertion. This made their bones strong and less prone to fractures, which would have been critical for survival. Section 5. The Expanding Mind, the Story of Our Incredible Brain Growth. One of the most defining features of human evolution is the dramatic increase in brain size. Our early ancestors, like Australopithecus, had brains roughly the size of a chimpanzee's, about 400 to 500 cubic centimeters. With the emergence of the genus Homo, brains began to grow. Homo habilis had a brain around 600 cubic centimeters. Homo erectus saw a further increase, with brain sizes ranging from 800 to 1100 cubic centimeters. This trend continued, culminating in Neanderthals and early Homo sapiens. Neanderthals, our close cousins, actually had, on average, slightly larger brains than modern humans, around 1500 cubic centimeters. Early Homo sapiens also had large brains, averaging about 1400 to 1600 cubic centimeters. This significant expansion in brain volume over a couple of million years is remarkable. Large brains are metabolically expensive. The human brain, despite being only about 2% of our body weight, consumes about 20% of our energy when at rest. So, there must have been strong evolutionary pressures favoring bigger brains. Section 6. A curious contraction: why our brains might be shrinking. Interestingly, the trend of ever-increasing brain size seems to have reversed in recent human history. Over the past 20,000 to 30,000 years, the average brain size of Homo sapiens has actually decreased by about 10 to 15%. This is a fascinating puzzle for scientists. If big brains were so advantageous, why would they start to shrink? Several hypotheses attempt to explain this phenomenon. None are universally accepted, and the reality is likely a combination of factors. One prominent idea is the self-domestication hypothesis. Domestication in animals, like dogs or cattle, often leads to a reduction in brain size compared to their wild ancestors. Domesticated animals are generally less aggressive and live in more stable, predictable environments, often protected by humans. The argument is that humans, in a sense, domesticated themselves. As we formed more complex societies with divisions of labor and reliance on social norms rather than individual aggression, perhaps there was less selective pressure for extremely large brains associated with individual problem-solving or aggression. Another hypothesis, sometimes called the idiocracy or know-it-all hypothesis, suggests that with the rise of complex societies, individuals no longer needed to know everything to survive. Section 7. Modern times, modern bodies, recent physical adaptations and challenges. The last few thousand years, especially since the agricultural and industrial revolutions, have brought rapid changes to human lifestyles. These changes continue to shape our bodies. One notable example is our jaws and teeth. Our hunter-gatherer ancestors ate tough, unprocessed foods that required a lot of chewing. They had large, strong jaws and relatively large teeth. With the advent of agriculture, food became softer. Pottery allowed for boiling and mashing food. Later, industrial food processing made foods even easier to consume. This shift to softer diets has led to a gradual reduction in the size of our jaws. However, our teeth haven't shrunk at the same rate. This mismatch is a common reason for dental problems in modern humans, such as impacted wisdom teeth and crowded teeth requiring orthodontic treatment. Our bodies are still adapting to these relatively recent dietary changes. It's a clear example of how cultural innovations, like cooking and food processing, can drive physical evolution. Modern lifestyles also present new health challenges that are, in part, evolutionary mismatches. Section 8. The future human: how technology might shape our evolution. Predicting the future of human evolution is a complex task. Natural selection continues to operate, but its course is increasingly intertwined with human culture and technology. For most of our history, environmental pressures like climate, predators, and disease were major drivers of evolution. Today, medical advancements have reduced the impact of many diseases. Technology helps us overcome environmental challenges. This changes the selective pressures acting on our species. Genetic engineering and other biotechnologies could play a significant role in future human evolution. Technologies like CRISPR allow for precise editing of genes. This opens up the possibility of eliminating genetic diseases. It also raises ethical questions about enhancing human capabilities like intelligence or physical prowess. If such technologies become widespread, they could direct human evolution in ways previously unimaginable. Section 9. The unending journey. Reflections on our ever-evolving story. The journey of Homo sapiens from our ancient roots to our modern form is a testament to the power of evolution. We have changed dramatically over millennia, adapting to diverse environments and overcoming countless challenges. Our physical characteristics, from height and bone density to brain size, have been sculpted by a complex interplay of climate, lifestyle, diet, and social dynamics. We are a product of this long and winding evolutionary path, a path shared for a time with other human species who are no longer with us. The story is far from over. Human evolution has not stopped. While the pressures of natural selection may have shifted, they have not disappeared. Our own cultural and technological innovations are now major drivers of our ongoing transformation. The shift to agriculture, the rise of cities, the industrial revolution, and now the digital age. Each has left its mark on our biology and continues to do so.